What's up guys? Welcome back to Vanover Customs. In today's video we're going to talk about how I built this beautiful slow speed carbide grinder. I'm doing some scraping on the lathe and I needed to get my scraper blades sharpened. And the best way to do that is with a slow speed carbide grinder. You can sharpen them on a green wheel, but slow speed diamond is best. And I didn't have that option, so I decided to build a grinder. I put some constraints on myself, mostly for fun and just to see what I could do with the given constraints. The first most obvious one is this is powered with a 12-volt Milwaukee battery because I wanted to use a spare Milwaukee polisher that I had sitting around. And I also wanted to do this with all material that I had sitting around the shop to try to make it a little bit more interesting. So let's jump into the video, and then once we're done, we'll come back and talk about some of the features that make this grinder unique. All right, we got our metal cut out for the housing, and unfortunately I don't have a finger brake, so we're gonna be doing this on the arbor press. I don't anticipate it going super well because I don't have full coverage, but I'm kind of hoping I can start in the middle, get it bent, and then come over to the corners and kind of clean it up, but we'll see. A little more. See, let me let off some pressure. Well, on the backside it looks pretty good. Yeah, sometimes you just gotta do some stuff that's weird, and this is pretty dang weird. Basically, I need to get a hole cut in the center here on the sheet metal, and I wanted a way to do that accurately. I wanna get it, within 30 thousandths or so. I thought about going on the mill and setting up a boring bar and trying to basically bore out the center, but being a large hole, I'd have to get it clamped on wood, and it's real thin. Thin work holding is hard in general. So actually this would be perfect for the four-jaw, but because I already bent it, makes it more complicated. And I thought about doing it before, but the swing of lathe I would need to clear that 36-inch piece would just make no sense. So it's set up, it's secure. We're gonna be pressing into the chuck, so the forces should be that. It's not gonna wanna make this pop out. I've got a double extension here, which I know is not ideal, just to get clearance away from the chuck, and we're gonna be spinning at a super slow RPM, and I'm wearing a face shield. All right, I think this would work. However, I think our insert's just taken a really large bite. So I'm gonna change to a different cutting tool and continue. All right, we've updated the tool, changed the geometry, and lowered the RPM. Let's see how we do. Well, didn't need the face shield, that's good. So we're gonna come out and bore the rest of that, and we'll be good to go. All right guys, let's bring you up to speed on where we're at. So we went ahead and got the case fully welded, and you can kind of see now the benefit of getting this welded nice and flush. It just looks really nice having the wheel recessed back into the housing. And also when we do our table, we can bring the table pretty close to the wheel, and we don't need to have a huge notch cut out, which is what you see most of the time. So that'll be really clean. We got a little access panel here so we can service the stuff that we need to service, and then that'll allow us all the room we need. We're gonna do a battery device here so we can plug in our battery, and that'll be like integrated into the lid, so that'll be real nice. But the next stop is we're gonna be working on the table. Now, most of what I see is pretty similar online. Either I see a really rigid trunnion setup underneath the table, which is what the AccuFinish uses, or I see people do a trunnion on the side, and that's totally fine. But most of what I see is when people have the table, their hinge points are way out here because it's more convenient to manufacture it that way. The problem is when you're adjusting your table, and you get it real close, like right here, you come away and you have a huge gap right here. And because we're gonna be sharpening real small stuff, possibly even inserts, I wanna see if I can keep that gap very tight no matter which way we adjust the table. In order to do that from a manufacturing or engineering standpoint is to take the hinge of where the table moves and move it as close as possible to the center line of the wheel. So that way as the table moves, that clearance stays the same. So we are going to do that so we can keep our table very close. But the other thing I want to do is I want to make this machine easy and convenient to use. And the reasoning for that is if it's complex to change the wheel or to adjust the table, you'll get lazy, you won't do it. But if it's quick and effective, you'll do it. And so that's why we have a quick change part for our wheels, and that's why I want to make this table effective but quick to adjust. So what we're going to do is we're going to weld 2 bosses on the side, and what I'm going to try to do is I'm going to try to design out that I've seen in other places but not used in this configuration, and we're going to use an expanding mandrel style hinge. So when I tighten my handle on either side, it's going to push a threaded rod into the bosses and expand them and hopefully grip the table. And the reason we're doing this is, one, I want to make sure that this is simple. A lot of what I see has a hinge and then adjustment below it, which gives you more leverage, which is totally fine, but that means we need to make a trunnion, and I just want to keep this simple and elegant, and I want it to work if possible. So we're going to just go with 2 bosses, and we're going to try to make the clamping mechanism in the actual hinge point, which is a little tricky, but we'll see if we can do it. So hopefully when we tighten these guys, it'll create enough force to grab onto the circles that we have cut out in the table and keep it in place, and it'll be super easy to adjust. All you got to do is undo the nuts a quarter turn and it'll be free, and then we go wherever we want. So it should be able to adjust in like 5 seconds and be rigid. That's at least the hope. All right, we're over at the Colchester lathe. We're getting ready to knock these parts out. We're starting out with a 3-inch hot roll blank. No idea how long it is, 4 or 5 inches. I bought a bunch of these for $1 each, and I've been using them ever since. Oh yeah, look at that thing. Doing work over here. All right, we're at about 3 inches. I need to rough this down to 1 3/4, so let's get to work. We're gonna do 200 thou passes. Look at that, doing work. I love it. Those chips are hot, I can guarantee it. Another 250 pass. This is why we have a 5 horsepower motor. We went from 3 down to 1 3/4 about. I'm gonna come in and take a couple cleanup passes. The outer dimension isn't that critical at all. Next, we're going to go down to 1 1/4 inch, 7/8 over. We're going to come in here and do our chamfers. Come in here with a center drill. And next we're going to drill our hole. This is just a clearance drill bit, doesn't matter the size. I'm going to come in with a 3/4 inch end mill, about 3/4 of an inch deep. I got the compound set up at an angle, and next we're going to turn a taper inside this hole. The angle, I have no idea what it is. It doesn't matter as long as it matches on the corresponding nuts that I make. I'm going to come in with a 29/64 drill bit and just clean up that hole for the tapped half 20 size. Just step down my feed. Next, we're going to do some power tapping with a hand tap wrench. I got it in a real slow speed. And we're going to get some lube on it. We're just going to get it started and we'll finish it by hand. Just doing it with a Lisle tap socket and a snap-on ratchet. That way I can feel when it bottoms out. All right, we're gonna get this guy parted off and flipped around. We're gonna do some power parting. All right, let's just get that back face cleaned up. We got it flipped around. Concentricity doesn't matter since we're on the second op here. So our drawing that we made specifies that this lip is a 1/4 inch. So what I'm going to do is I'm going to come over to our chuck and just kind of touch off, zero the part, come back 250, zero it, and then that's where we're going to stop. I'm going to come in here and get a measurement. Well, there's our part, guys. We just need to go and slit it a bunch of times so that way it has a springy nature like a collet. We have our taper in the center, we have our threads going through, and we just have a boss that we can weld on to hopefully try to minimize distortion in this part here. Other than that, we need to make a second one and we need to get this one slid up. The next step is to slit this part. I figured why not do it on the K&T mill using our super spacer. So we got everything dialed in and set up and centered and locked down. We're gonna make it in one pass. Currently I'm running 165 RPMs and a feed rate of 1 3/4 inch. We'll see how it does, if we're gonna need coolant or what have you. Let's get started. I am cutting into my jaws, I'm not too worried about that. I think I'm going to step it down. I'm at 1.5 inch feed rate. I'll go to 1.25 inch. We're at 1.25 inches a minute. All right, this is the last cut, guys. I don't know about you guys, but I am really, really happy with the way this is turning out. Yes, do we have some vibration in the cutter? Absolutely. However, it doesn't make any difference for what we're doing, it's gonna do a good job. I'm really, really impressed with the KNC. Not that this is a hard job or anything, but just that I have this machine and can do this. This is way easier over here on this machine than trying to do this on a Bridgeport. This cutter has good support, and it can give us a really, really nice result between the rotary table and the rigidity of the machine. I'm really happy with the result. Well, we got the bosses welded on, and I'm really happy with how it turned out. Because the center line of this needs to be in line with the wheel, we went ahead and machined and split some half nut type deals to capture the ends of these, so that way we could keep them on center. And what that allowed me to do is weld the inside of this to this. So really all we need to do is just weld this fillets on both sides to the case. But before we finish welding that, I want to get the table on here and make sure it's going to work, because if we need to tweak this design, I don't want to be cutting off something fully welded, and it is, you know, experimental. So it should be fine there. We're going to make the clamp bolts next, and then start working on the arms and the table, and then see how everything lines up. Back over at the blue lathe, and we're going to go ahead and make these knurled knobs that have a taper on them. So we'll get these guys turned down, it'll be knurled, it'll have a taper, and then it'll have a half 20 thread. I'm just going to start out by creating a round surface, and we'll touch off. I'm just going to use that smooth surface to chuck on. So that way if we do have to take it out, which I'm going to try to avoid, we can try to keep it a little bit more concentric, having a nice machined face in here. Go ahead and center drill this. Next step's to do some knurling on the part. We're doing a 2.5 inch diameter. The limit of this knurler is 2 inch, I believe, so we'll see how well it works. We're running a slow RPM and lots of lubricant. A lot of tool pressure, but we got it. That's why you always do the knurl first, because if there's issues with that, you don't want to be doing that at the end. Next step's to rough this down to 1 inch. Like we're 25 thousandths away. Next, we're going to bring this down 3/4 of an inch over down to 1/2 inch OD for the threads. All right, we got a boring bar chucked up. We do have the compound set from the last time we made the external part. So now we're gonna cut the taper, running the lathe in reverse on the back side. All right, we're ready to do some single point threading. We got our part blued up. We have a top notch insert. I can't seem to find my threading gauge, which is a bummer. I'll find it when I get the shop cleaned up. But I do have a 1/2-20 set screw. So we'll do a scratch pass and test it with that and then move on. All right, we're looking good. I found a tap that had a little bit of a sharper peaks and valleys. So that's what I just wanted to make sure we're good to go. Slowed the speed down because it's moving a little quick since I got to pull out. One trick I like to do is just take this point or where you're threading and move it away from the work a little bit. That way if you miss the number, you're not right up on the thread. According to this, about 25 thousandths away. According to that, we are within 2 thousandths. I'm gonna leave it there a little large. I think if I need to, I can clean it up with a die. We'll chamfer the end, get it parted off, and we'll be good to go. I don't want to do too much of a chamfer. I want to keep as much thread engagement as we got. We can do a nice chamfer here though. Tool does excellent. TGFH insert, I believe. All right, let me bring you up to speed of some work we've been doing off camera. So we did get the knurled knobs done, both sides, and they do work. And then I went ahead and made 2 brackets for each side. They're pretty easy, they're just out of aluminum. The most difficult part is boring the holes correctly so that way these do move, but it's a nice tight fit and the handles do their job. So after some testing, good news, this method does work. The bad news is it's pretty manufacturing intensive, if I want to say it that way, to make them. So I figured out that these expanding mandrels do expand, but it's only about 5 thousandths, and I messed with the taper and that's about the best I could get it. And that does work when you make these a nice tight fit, but if this is 2 or 3 thousandths bigger than it is right now, it's not enough expansion to hold it. So right now, how I had it, if I crank down on one side, I pretty much couldn't move this, and we're gonna have 2 sides, so that's plenty. But I really had to spend some time dialing in the right bored hole so that this was a perfect fit. So I'm really happy with how it turns out. Next step is to come in here and cut out and make a plate, so that way we can have a spot for the table. And we went ahead and machined these down to try to drop down our plate so that it's on center and aligned of the wheel. Again, that doesn't matter in relation to the wheel, but it does matter in relation to the actual hinge. The hinging part is on center, but if you want the top of the table to be on center, then that's what we need to do. So let's get that top plate made and go from there. I splurged and ordered a piece of 3/8 aluminum plate from McMaster-Carr. You can see back here, I had the material I needed for the job, but I really just didn't want to mill down all that material. And also when you mill down that much material, it has a tendency to move. So I went ahead and paid for a nice 3/8 inch thick piece. That's going to prevent me from needing to mill it down, and it'll be uniform thickness. So we'll get this cut. I'm going to cut it large and then we'll mill it down to size. All right, let's get our aluminum table dropped on. Very nice. If I hold the sides, you can kind of see how it's going to work. That's going to be really, really nice. So the next step is to go ahead and just put 2 holes on each side. I purchased some countersink screws that we're going to go ahead and tap the bottom and install those. And then the next step, which I didn't mention, is even though this is close to the wheel, it's actually not as close as I would like it to be, but I want to be able to change the wheels in and out. So what I'm going to do is I'm going to hard mount this to the mounts, and I'm going to create a whole nother piece on the top, and I'm going to slot the bottom piece, so that way this will provide the base and the other piece will slide on it. So once I get the wheel on, all I got to do is come under here and adjust a knob and slide the top piece right up to the wheel. So I'm like a sheet of paper away if I want to get it that close. And then if I want to change the blade real quick, undo my thumb screw on the bottom, slide it back and get in there and have enough room to change the actual wheel. So that'll be the next thing. I ended up cutting my tacks, bolting all this together, and then re-welding it to keep it in perfect alignment. I kind of had a feeling I needed to do that, and it was close, but I wanted to get it perfect. It actually was necessary for me to do it that way. That way I could properly measure the distance for these and for the table. But now that I had the table, getting the tacks cut and re-welding it just allowed everything to be securely clamped while we welded it, which allows for really good alignment. I'll get the knobs on there, but this is looking really, really nice. Well, this is exciting. We got the knobs on, and I just want to demonstrate this working. And this is quite a feat. It's loose here. Come in here, tighten it, nice and tight. Come over here, loosen it, loose. How amazing is that? Easy to adjust, nice and solid, exactly what I wanted. Worked great. All right, we got our final top piece made, and this piece is going to allow us to be able to creep right up to the wheel, and here's how we adjust it. So taking a look at the bottom, I have a slot in the center, and I have 2 keyways pressed into the aluminum, and then I have 2 slots on this with a stud welded to the bottom. And what that can do is allow us to drop that on here, and it tracks nice on those keyways. And then I'll have a thumb screw or a knob on the bottom so I can tighten this instantly. So what I can do is pull it back, flush or beyond, so I can swap the wheel. I get the wheel on there and push it right up close to the wheel. So if I take a small insert or something real small, I can get it right up to the wheel without it falling, and I can easily adjust whatever clearance I want. So this will be real nice. All right, we finally made it to the finish line and we got this grinder finished up. And I'm really pleased with how this thing turned out. The project was very complicated, but in the end of the day, I think it really paid off because I think we have something that not only looks great, but works and works well. So let's go over some of the features that make this baby unique. Probably one of the coolest features of this grinder is the fact that it is cordless and it uses these nice Milwaukee 12-volt battery packs. Both the bigger battery packs and the smaller battery packs work. So theoretically, if we wanted to move it around anywhere in the shop to where we are working, we can do that without needing to plug it in, which is cool. And then also we integrated the trigger from the polisher so that way we have a nice variable speed nature and can really dial in the speed. I don't have an RPM measurement device, but I did count the RPM revolutions with a timer, and we're getting anywhere between like 60 and 400 RPMs. So that's really nice. It gives us that nice 300-ish RPM range, which is where the AccuFinish is. And we're also running a larger wheel, which is cool. Moving over to the business end of the grinder is our actual wheel. Now the design of this wheel is really important in terms of usability. Now, if you look at the AccuFinish, and the reason I've mentioned that before is it's pretty much the gold standard in slow speed grinders, and unfortunately, they don't even make them anymore. So if you want to get something like that, you either have to buy it used or you have to build one of these. But AccuFinish being the gold standard, if you look at their wheels are actually diamond, like an adhesive glued onto the wheel, and then the whole wheel itself is interchangeable with a nut. The problem with that design is that every time you want to change the wheel grits, you have to undo the nut and pull the whole like hub is what I'll call it off and switch. And when you buy AccuFinish, you can get a kit that has all the wheels, and obviously the wheels are pretty pricey, $200–300 each, and you need multiple grits. I wanted to design this wheel around a better, more efficient and cost-effective way to switch out the actual wheels and obviously have a cheaper wheel. So I took a page from Stefan from his slow speed grinder, and we use these lapidary wheels. Now his grinder and a lot of other grinders on YouTube use a 4, 5, or 6-inch wheel, and I really wanted to use an 8-inch wheel just because I thought it would be cool to have a bigger wheel and have more area to work. So what he does on his, which I have copied, is he uses a pin to drive the wheel. His actually uses 2 pins and then a actual like boss in the center to register it. And the wheel uses magnets so that way you can come in here and change the wheels. And the reason that's important is if something is difficult to use, you're not going to use it. AKA if the wheels are hard to change, you're going to avoid changing them and use whatever grit is on there. My design, very similar to Stefan's, it uses a slot in the wheel, and I can get in here with a pry tool, and I can actually come in here and take this wheel off and swap out the wheel really easily. And that's really nice so that I can come in here and change the wheel rapidly. Probably one of the biggest opportunities for improvement on a lot of the slow speed grinders that I see is the table. There's a lot of things that I did with this table that are different than a lot of the tables out there, and I wanted to address some concerns. The primary thing is that most tables you see, the hinge point of the table is far away from the center line of the wheel. Totally fine, not a big deal. But what it does is when you go to adjust the table up and down, the clearance gap between the table and the wheel changes dramatically. So what I wanted to do is I wanted to take the center line hinge and put it on the center line of the wheel. That way when I adjust the table up and down, the distance between the table and the wheel stayed relatively constant. And what that would allow me to do is just stay closer to the wheel and keep that consistent. By doing that, or in order to do that, what I had to do is I had to move the hinge points directly in line with the actual wheel, which made doing that a little bit more complex. But in the end, it makes for a much nicer experience because the table itself stays in a very similar state in terms of the gap between the table and the wheel when you actually rotate the table. Another area of improvement was the actual clamping mechanism for the table. Most of the tables have a trunnion underneath or a traditional style hinge here and a clamping nut down there. And I really wanted to simplify the design and make the hinge and the lock in the same mechanism. And we were able to do it, and it worked out really nice. All you gotta do is get these guys tight by hand, and the table is locked, really rigid, and then come in here and loosen it, and you can easily adjust the table. And I'm really happy with the way that turned out. It was kind of a pain to make the mechanism, but overall, really, really nice, easy, efficient, and effective. The last feature that I wanted to incorporate into this grinder was an adjustable tabletop. Adjustable in terms of the clearance to the wheel. Now I see a lot of these designs with a gap here so that you can get the wheel on and off. And also they do make ones with adjustable tables, but I wanted to integrate both into the same part. So what we did is we created a bottom table that has 2 keyways in it, and then a top table that has 2 slots milled into it. And what that allows is to come underneath with a thumb wheel and basically take the table in right up to the wheel and adjust it exactly where we want it. So that way, if we're at an angle, we can go ahead, like for example, we can move this down and I can bring this right up to the wheel. Or, you know, if I'm in the opposite direction, the same thing. That's really, really critical when you're grinding, let's say an insert, for example, because an insert's really small and you want to be able to come up here and just dress the edge, but you don't want it falling through. So that's really nice that we can get it up right to the wheel, and then really simple, on the bottom there's just a thumb screw, we tighten it and we're good to go. And then if we want to make an adjustment, a quarter turn, slide it out. If we need to change the wheel, we can get as much clearance as we need. And here's a shot of that thumb screw. Real nice, you just loosen it, tighten it, and then you can slide this in and out. All right, I've been blabbering on for quite a while now, and I think we all want to see the same thing. We want to see this machine work. So I have a Sandvik solid carbide blade here, and it doesn't have a radius on it. It's just straight across, and we have an 80 grit wheel for roughing. So let's turn this guy on and let's get a radius ground in on it. Look at that, it's a pretty nice result. I know my line across the middle isn't exactly perfect, but this is the first time grinding a blade, and so a little bit of my skills need to be honed in. But I brought it all the way up to 1200 grit. We have a nice little radius on there, and I'm really happy with the way that turned out. So I think this will work perfectly for scraping and for getting my blades touched up and also touching up my carbide inserts. Well guys, if you've made it this far, you probably earned yourself a badge of honor. This was an extremely long-winded video and very detail-oriented, but for those of you that appreciate it, I'm sure you do, and anyone else has probably stopped watching by this point. Hope you enjoyed the video. If you guys have any questions, post them down below. We'll see you in the next one.